We want to talk to you about Vega today, about the team, and about what we want to do in the future with Vega and the technologies that we're developing. All right, so really quickly, Vega means in Sinhalese speed, Vegen Yanage. So we wanted to build a high-performance supercar. That was about 2 years ago. All right, so this was a picture taken 2 years ago, roughly about 2 years ago. This was because we didn't have a space by then. Trace Expert City was not open. So we started some of our work at our home garage. So this was, we built a Lotus chassis at first. It's a Lotus 7 chassis from the 1970s to get a rough idea about, building a space frame chassis and the dynamics of that. So this was our, humble beginnings 2 years ago. Then a few days later, we developed, we were just bored. We made a small YouTube video about Vega, and we really didn't know much about building a car or how long it would take. So we kind of put this video together.
नाम देवाती सब्बे बुद्धा समग्गिका
So that was 2 years ago. What you don't see in the last few frames is that we committed to a date of building the car in 1 year, because we really didn't know, what kind of challenges we will face. And really, even now, we will put very aggressive goals in front of us so that we really push ourselves to innovate and to do things that the rest of the world isn't doing, that we could do it quicker with the resources that we have in Sri Lanka. All right, so simply our objective is to build a world-class, high-performance, all-electric supercar right here in Sri Lanka for the first time ground up. So this is our number one task. When we started this about 2 years ago, there were many ideas. Harsha wanted to do something new for CodeGen and new for Sri Lanka that was never done before. So we looked at a number of things, a car, other devices and electronics and so on, as to what we really wanted to do. A car is something that everybody can connect to. Everybody uses some method of transport. And a supercar, a sports car is something that people can easily connect with, and there's a lot of technology. A lot of multidisciplinaries come together, mechanical engineering, electronics, electrical, materials, chemistry for batteries and other materials for the car and so on. So a vehicle is an ideal place to do a lot of innovation that majority of the world uses. All right, so we have three goals in our project with the Vega prototype that we're building. One is to do 0 to 100 kilometers per hour in 3.1 seconds, or 3.6 seconds, a top speed of 240 kilometers per hour, and a range of 240 kilometers per electric charge. So if you look at the Nissan Leafs today, once you charge the vehicle, you can do about 150 to 180 kilometers. So this is also a complete electric car. There is no petrol tank or engine or combustible engine. So once you charge, we want it to go 240 kilometers per charge. All right, so I want to stay on this slide a lot longer than the rest. So this is our team. We have 8 full-time employees. That's part of this team. We have a material engineer, 2 mechanical engineers, 2 electrical engineers, and about 2 electronics and a program manager. So this is how we kind of set ourselves up. Apart from this team, we have a number of student interns and trainees who are part of our project. Right now, we have 23 from about 6 different universities. We had the honor of some of your WSO2 employees doing their sabbatical with us, which was a awesome experience. So thank you, Assis. So really, a lot of people, when they talk about Vega, or they say, "Oh, this guy from Intel came here, 2 years ago to work on the car," and so on, and so forth. But really, this project is done by ordinary, Sri Lankan, youngsters who have done extraordinarily well in their studies and at their universities, and now part of this team. So credit goes to these guys for pulling this off. I, of course, just have built expertise in PowerPoint now. So all of the mechanical engineering, the software, the firmware that's been written, the electronics, the electrical, the simulations and so on, everything is done in-house by this team. So credit goes to them. And these guys come from all parts of Sri Lanka, from all walks of life as well. The furthest guy we have is from Nikavaratia. He travels about 7.5 hours on a Monday morning. He leaves home at about 3 a.m. to get to work, and he goes home on Friday evenings. Elephants roam around his backyard. We think of cool projects and we think it's all Colombo or this and that. But really, this team is from every part of Sri Lanka. So it really shows that if you really wanted to do something new and do something novel and innovate, the limit is endless, and everybody can be part of this process. All right, so quickly I'm going to go through some slides about some of the technologies of what we're doing. So before any of the car components are fabricated, everything is modeled in computer. So you can do structure analysis, FEA analysis, wind tunnel simulations, aerodynamics, and so on to really have an industry level, world-class design. We talked to a 25-year veteran from Volvo, another Sri Lankan, and we try to follow the process that Volvo does. And about 99% of their work is also done on the computer first. So every car manufacturer is now moving from doing actual, crash testing in the front of the manufacturing process and really doing all of that on the computer now. So because the simulations are getting so accurate. So this is a picture of the surface modeling. We took about 6 months to get from the drawings to getting a complete surface modeled CAD, a Class A kind of a model. So this is those initial, modeling that we did. By the way, this design was done by a guy called Dash Gunaratna. He lives in Colombo. He has a automobile engineering degree from UK, and much of the world-class standards on automobile design and engineering is used. Of course, there are gaps. When we get into certification, we will have to do some modifications, but we are trying to follow as much of the industry standards as possible. All right, so this shows all of our packaging. On the top picture shows all of the components that go in the car. Everything is modeled. every nut and bolt, every little bracket that gets welded on is modeled first. So you know how the weight distributes, you know how the forces and the, you know, what kind of, you know, space that you're talking about. So we have a space frame chassis which you see in the black tubular kind of shape, and then the body panels will be out of carbon fiber. The whole car weighs about 1,500 kilos, about the weight of a Toyota Prius, maybe a little bit more than that. And it has a 6-inch clearance. So a common question we get is, you know, can you drive this on our roads? Yes, you can, because the Toyota Prius has about 5.5 or 6-inch clearance as well. So if you can drive a Toyota Prius, you should be able to drive this car very easily. It's a rear-wheel drive car. There are 2 motors. Each motor is connected to a rear wheel separately, so there is no mechanical differential. Software will control when you take a curve, you know, depending on the speed of the car, the steering angle, you know, how to rotate the 2 wheels, because all of us obviously know that when you take a curve, one of the wheels have to turn faster than the other one. So that is all done through a computer. There will be about 50 microcontrollers on this car. There will be a device for IoT. There will be a touchscreen display running maybe a Linux-like kernel. And the whole system is integrated using a CAN bus. But there will be Wi-Fi connectivity and remote monitoring capabilities as well. So there is a lot of software that will go on this car. And something that we really you know, want to tell all the software folks is that because you will have all of the access to all of the sensors on the vehicle, the actuators, the brakes, accelerator, you can, you know, start writing autonomous navigation code, or, you know, accident prevention code, or, you know, something smarter than what's available today. And people ask, you know, how could you do it in Sri Lanka, you know, with our roads and so on. But, you know, that's where the innovation comes. And I'm sure if we put all our heads together, we can really think about how to, you know, drive this car safely in Colombo. All right, so the bottom picture shows a 3D scan of the vehicle. We borrowed the high-precision laser scanner from University of Moratuwa to scan our plug, to make sure that it matches our simulated surfaces and make sure that the errors are all fixed. All right, so this picture shows the chassis and the aerodynamic simulations. Again, you know, a lot of things can be done in computer now. So the top picture shows the kind of the forces that will be placed on the chassis when you do, you know, curves and high speeds and so on. And the bottom picture shows some of our aerodynamic simulations as well. Sorry. So this shows the modeling of our motor controller on top. There's only about 2 other motor controllers in the world that we could buy off shelf. So we thought of building our own to see, you know, to really get into the technology, to build that expertise so that we can get into other technologies through that. The motor controller will be rated at 600 volts, running about 600 amps. So it should be able to do about 100 kilowatts of power per motor continuously, about 150 kilowatts of power at peak, which roughly converts to about 900 horsepower, available horsepower on the car. We think we should be able to run around 530 horsepower to achieve about those 3 goals that I talked about. And the bottom picture shows the battery module that we are designing as well. All right, so this is a real picture. This is our plug, which is a full-scale model of the car. This was taken about 4 months ago. We have moved much further now. So out of this plug, you build the mold, and then off the mold, you build the body panels out of carbon fiber. So it's a 3-step process. The first process of building the mold very accurate, building the plug very accurately is the hardest part, and that's what we are doing right now. All right, so quickly, apart from the car, we are also building electric vehicle charging infrastructure. Because this goes in hand with what we're doing, and all of our technologies that go into the motor controller matches very easily to the power electronics areas of, you know, fast charging. So what you have on the top is the fast charger that we built for Nissan Leafs and so on, that adheres to the CharDemo standard. And on the bottom, on to the right, is the it's called a level 2 charge. It's a slow charger, completely built in Sri Lanka as well. So these are being deployed around the country now. We have about 15 charging units around the country. So if you all, I don't know if somebody owns a Nissan Leaf, but we have what we call a ChargeNet charging solution. So all of the chargers are IoT devices. They are all connected to the web using a low bandwidth connectivity. With IoT devices now, it enables us to have a membership system. It enables us to give real-time information about our chargers. You know, is it busy? Once you're driving to Kandy, you know, what kind of chargers do you have on your way there? You know, is somebody charging it? What other charger can you use? You know, these kind of information can be done using this technology. All right, and then we have a mobile application as well that that gives you, you know, real-time information about the chargers and where you can get, you know, your vehicle charged. All right, so this video is the first drive of Vega when we had the battery and the motors all attached to the test platform. So this was a big day for us. This was about 1 year and 8 months of work to get to this level. We are able to do about 80 kilometers per hour right now, and we are developing the motor controller in stages so that we can break the 100 kilometer hour milestone and then move on to our 240 top speed goal. So this is the first time we ever drove this car using all of our electronics, all of our software. The two motors were brought in from the US, but the reduction gearbox that sits in the middle and all of the electronics is done locally. And yes, it goes in reverse. With electric car, reverse is very easy. You just, you know, it's just a software switch. So it has, you know, regular brakes. Brakes are not fancy right now, but the new Audi models have complete electric brakes. There's no hydraulics at all controlled through software. So we want to get into that kind of technology in the near future. And we have built this car so that it's autonomous capable, meaning everything can be controlled through software if needed. You know, if the capability is there, it doesn't. So this is the Trace Expert City side. If you all ever come to visit, just cross the road very carefully. No, I'm just kidding. So a few more seconds of this video. All right. All right, so I'm now going to call upon Dr. Harsha to come talk to you about, you know, where we want to go from here. Thank you.
Okay, I don't do any of the work, so all what I do is give some kind of vision where we want to go and what we have to do. So we have come so far with this particular car. So I'll give you what you want to do. I think I don't have that much of time. The first thing is, like, we thought that, okay, now if we can go, I was asking the guys that we have two motors which do 900 brake horsepower. Then when I went and had a look at the Lamborghini Aventador, it has 600 brake horsepower, and it actually does in 2.9 seconds, and it's about 1,500, 1,600 kilos of weight. But ours is about 1,500 kilos of weight. We have 900 brake horsepower. So we thought that why can't we do 0 to 60 in about 2.1 seconds, right? So now so I told all the guys, our ambitious target now has to be changing from 3.6 seconds to become 2.1 seconds, taking the statistics from Lamborghini, right? And the second thing is we will actually now realize that with the electric brakes, we will be able to do the 4 motors because we get enough space in there. And then we realized, why can't we reduce the weight of this particular car? So from 1,500 kilos, if we can reduce to about 1,100 or 1,000 kilos, then we have better chance of having better acceleration. And also to use space-grade material. And also, one of the other things I was telling the guys, the most coolest stuff, if we can charge our car in about 10 minutes, right? So we realized if you can have a software configurable battery set where you can do serial and parallel. So it goes to parallel whenever you want to charge it. It goes to serial whenever you want to drive it. So you can reconfigure the batteries using the software rather than just having pre-configured battery set. So we realized it's all possible. So now, in order to do that, if you do a car on 2.1 seconds, then the whole world is going to know there will be a car that's developed in Sri Lanka which runs at 2.1 seconds. So that actually gives us a tremendous boost. And that's the ambitious target that we have for the next set of goals that we set up today. So then I realized, how am I going to get this car weight reduction? Then I went to, we have a nanotech park, absolutely fabulous place. So I went and I spoke to all the scientists over there and say, is there any way that you can actually build us a material which can have the strength that we need, and also we have the flexibility as well as the lower of the weight. And then after long discussions with them, and they said, okay, there is a possibility that we can actually build a type of polymer that you're asking for. So what you're doing is like they're actually using some kind of peak material, that carbon infusion in there. And then now at the moment, we are testing and trying it out, and we are trying to see whether we could actually make the same shell using the new material. So if you do that, we can actually drastically reduce the weight of the chassis, which will go down to about, I think, go down by 400 kilos. So that's another thing that we're trying to do with the nanotech park, and utilize some other resources that we have it in Sri Lanka. And nanotech park is not actually been known very well around the world about the Sri Lankan nanotech park. So we think that by doing these kind of things can give a tremendous boost for them. The next thing we thought, okay, what if we can, rather than going through the plug and the entire model, is there any way that we can actually do 3D printing of all these panels? So all what you have to do is like you have a chassis, and all what you do is you design your car and you 3D print your panels and then fix that one into the car. So this is like kind of quite ambitious, but we are trying our best to do that one as well. The next one is, in Sri Lanka, one of the biggest problems that we've seen is in the grid, we can get only about 30 to 40 amps. Now, if you have 30 to 40 amps, it will take a long time to charge up like 100 kilowatts of power. So what if you can store that energy over time in somewhere? As soon as you get the car, then you download all that energy into the car as fast as possible, right? So in saying that, we said, okay, why can't we build a kind of a supercapacitor in Sri Lanka where you can do that? Then again, that we went back to nanotech park and said that is there any way that you can create us some kind of material where we can actually charge during the peak, off-peak time, those capacitors, and discharge back into the cars as fast as possible. So we are actually working on those kind of material and trying to create a supercapacitor where we can actually store that kind of energy and then download that energy into a car as soon as the car comes. So that will actually resolve the power problem that we have using the electric cars as well. And thirdly, as Bishan mentioned, that we have about 50-odd microcontrollers, and we have now creating our own API. And then we also work on some of the drones technology, like autonomous drones. So those algorithms that we have done on autonomous drones are working now, and those technologies are now become the most, I think, stable algorithm in the world today. We have few research papers that has been produced under that as well. So we are actually trying to see whether we can actually make the Vega to become autonomous as much as possible. So that's all open to all the people, all the software guys, so all the software folks to use our APIs and use the controllers and to build autonomous car. So I think so many other people are already building it. And then we also build the autonomous part of Vega as well. And then what we realized is like if you get all that thing done, is there any way that we can go into e-racing or Formula One e-racing? It can be, sounds as crazy as possible, but if you have the right motors, right controllers, right battery packs, and then right material and right weight, then why can't we go and do a e-racing on Formula, right? So it can be the right time and the right place as well, because it's not been started as it has always been starting. So there's a big possibility that we could actually go into the Formula One as well. So if you can go, as a country like Sri Lanka, never been known before for automobile industry, and ended up in Formula car, I think that will be the coolest thing that somebody can ever do. So that's the biggest ambition that we have. So saying that, everybody asks, how did all these things started, right? So I can actually say that one in so many different ways, but I can simplify the entire thing. Say like when you hit the midlife crisis, right, you wanted to have a faster car, right? When you want a faster car in Sri Lanka, it's extremely expensive. So if you want to drive a Lamborghini, it's going to cost you about 1.1 million. So I thought that, is it possible to spend a 1.1 million on a car, or you invest the entire money on building a car, right? So the journey started thinking on that particular line and say, rather than buying a car, let me build a car. So if you build a car, what you can do is like, you'll probably be able to sell the car, and then you can make sometimes serious amount of money if it all works, right? Or you can sell the technologies and you can make other stuff as well. So finally, you will be able to build a car of your own and the way you like it. But the coolest thing, what I told the richest guy in these countries, if I'm driving a Vega, right, it's under my control whether to sell it to you or not, right? So just imagine the coolest thing is like you go to the richest guy and say that you don't have the Vega, right? So what can they do? I was telling the Emirates president the other day, when you meet the Sheikh of Dubai, tell him whether he could afford to buy a Vega or not, right? Whether he has a Vega in their car or not, right? So that's actually a kind of the super cool thing that we started off taking this particular Vega kind of a car into the market. And so when we started the Vega, we did not think about market analysis, SWOT analysis, this analysis, that analysis. We say, okay, let's get on with it. Let's start it. Let's start how it actually goes. And then let's start to fund it as much as possible and see what it takes us from there to the next level, to the next level. So the good thing is like most of the Sri Lankans now, it's kind of open to every single person. So a lot of people, a lot of kids, a lot of companies, they want to come there and want to contribute to this. And that way, this has actually become like the Sri Lankan car or the Sri Lankan thing, which actually gives a tremendous boost for all the Sri Lankans, because they are so keen, and some given time we will have so many people turn up in our doorstep and say, is there any way that we can actually contribute to this particular car? So it is actually happening at the moment, and I think hopefully that all our ambitious targets that we can meet, and then hopefully this will actually go into a kind of a business model that can actually develop into a massive industry in this particular region, because nobody has ever tried it before. And lastly, one of the things that typical question that all the Sri Lankans and anybody ask is, why do you really want to develop a faster car when you can actually develop a kind of a Maruti or a small Suzuki or something like that? Now the difference is like, if you want to make a sort of fast-moving car, you need a lot of robotics. That costs you a lot of money. So if you want to make more margin, then you need to make more automation. So to do that automation, it costs you a lot of money to have those robotics and stuff like that. But if you go for a kind of a handmade car, you have a lot of labor or cheap labor available in Sri Lanka. So that way that you can actually make a handmade car and go into a market like Zonda and Koenigsegg and that kind of a very high market, upmarket car that way that it actually fits the bill of these kind of regions straight away. Once you become successful on a very high-end car, then you can downgrade it, and then you'll already build a reputation, and then you can go to a smaller car as much as you like. And that's the reason that you can see even all the Ferraris are downgrading to smaller cars as well now. So that's actually answering the question of why you actually did not make an electric tri-show and went to a bigger car. So that's all we had to say about the Vega, and it's actually keep on moving, and hopefully you guys can see in about a few months the full run of the car. And my time is also running out, and I wish you all the best, and I hope that you enjoyed in the WSO2 conference. It's the most admirable one of the companies that I have. I always take WSO2 as an example for whatever Sanjeev has done from there to give an international momentum. So hopefully Vega can do some kind of thing to the country and impact the entire country as well. Thank you so much.